Right, just so you know which one's which, I'm Paul, he's Rob. Thanks everybody for coming today, and thanks for the great timing of this slot in the agenda, Liam, because I think we've going to show with what we want to discuss around Insight about how Insight can help to answer some of the questions that have already been posed and some of the challenges that have been posed and some of the challenges that the business faces today in delivering maintenance and how we can help. So we're going to talk today about the Insight tool, which is part of the Intelligent Infrastructure Programme. It's a tool aimed across maintenance and covers both track signalling and it will eventually cover EMP as well. But today, prominently, we're talking about track. We would like to start, though, with a little bit of a survey, if Liam can activate the necessary survey. And we'd like you to indicate what you know about Insight and why you think, if you do know about it, it will improve the way you manage track. I'll stop there then. So, okay, looks like it's settling down. So no, that's pretty much what I think Rob and I thought the reaction would be. Much of a range across all the answers. Interesting, the ones that don't know about Insight, and yes, it already is, and how it will help. Hopefully, by the two I don't know enough about Insight and how it will help, we'll answer today. So Insight takes data from measurement trains. We take the data exactly that comes in the current PDF traces that everybody gets. We just run it through some various extra processes like aligning the data so that you can have aligned data from measurement trains, anything up to the last 12 runs of data. So no longer having to search through pieces of paper and try and find out where your exceedances are or any issues are. The tool's almost doing that for you. So it's taking that data, it's plotting that out, and you can see this is over a trace. This is a top trace, and you can see the run-on runs. The little flags at the top, they indicate where there's other issues in the track at the same location. So there may be other faults, could be PLPR, could be cyclic top, could be other track defects. What we then do is we take that sort of blue shaded area, which is over a distance, we turn that on its side, and now we're looking through time. So we can look back, in this case, just to prior to March 22, and we can look at what the degradation is over that piece of track over that time. And that degradation chart also includes any interventions that have been made, so we can look at how effective our interventions are made. So as Peter talked about earlier, the whole sawtooth, how every time we make an intervention, are we getting the same result? Is the impact diminishing over time? And again, you've got the markers to say what defects are in that location, and then you can see there a projection line. So we're projecting based on linear regression, which we found is to be the most effective way of measuring this, what's going to happen to that defect over time, when it's going to pass through the thresholds. And Gareth talked about those thresholds being challenged in some ways, and we know there's some work going on with this in universities. These are the thresholds that are put in from Mod 11 of Tractor Below 1. We're also working on, and the bit Rob will talk about and major on, is putting those in as RBM thresholds. So if you've got an RBM regime that varies these thresholds, then the tool will react to those accordingly. The secret of this tool is this is not a tool to tell you how to do your job. This is a decision support tool. So the question was asked earlier, how can technology help? This is where technology can help, hopefully, because it's starting to give you a lot of information that currently is in many, many disparate systems across Network Rail, pulling it all into one place and allowing you to manage things from one place. It's not the finished product. There's bits more to come in later on this year and into next year, which we'll talk about in a minute, which will help that even more. There's a couple of case studies in these slides, and I know these slides will be shared afterwards, but these are some examples of how currently your colleagues are using the tool. So Matthew Grace has been using the tool to help him analyse rough rides. So he can look in the data, he can see what's happening within the data, and he can understand all the factors that are in there, so he can look and see, in this case, found out there'd been some drainage work done, because the drainage work orders are in the tool as well. So not only can you see what's happening from a track perspective, you can potentially start to look at root cause of why you've got that issue, because other work's been done, or not been done, as in some cases. So in this case, Matthew was able to look at how quickly he could take off a speed following a rough ride report using the data and the analysis that's within the tool. And you can see how previously we've saved a lot of money by identifying these. We also, for the first time, start to show cyclic top in the tool. So instead of previously you had to request to see your cyclic top traces, these are now presented within the tool. So these are show cyclic tops that you might not even know about today. It's not even reached Cat D yet. But as we can see here, we've found in a lot of the analysis that when a cyclic top appears, it can come very, very quickly, because there are major step changes in the energy that's building as part of that impact, caused by a trigger point somewhere in the track. And what we're starting to do is show these and how these peaks are building over time, and then again projecting forward. When's it going to pass Cat D? So if it's going to be a Cat D in the next 90 days, the tool will present that as a risk site for you to go and look at. Quickly, you can swap between the different charts in the tool to go from cyclic top to look at potential triggers. So can I see a dip that might not be reportable as a dip in its own right, but is a trigger for that cyclic event? We've also got PLPR in the tool, so there is already a TV in place that allows you to manage your TEF 3225 and 3226 defects through the tool now. You now start to get the images that normally come through on the PDFs. We've put those into the tool as well, and now you can do a lot more with those images. You can blow them up to full screen, so you can and then zoom in even further, so you can really start to drill down into what can I see in that image. That then potentially means I can reach a cause of action from looking on the desktop images and on the traces you're getting. Again, doesn't negate the need for somebody to go out to site potentially, but can help in reducing the number of times we need to send somebody out. And then what we do is, as we said there, for looking at cyclic top, this is where we can combine everything together. So we've got a cyclic top trace, we know there's an issue. We've got a defect here in this case, which is a non-reportable dip. And we can see the image that this dip is on a joint. We've got all that information in one place now instead of having to look in different places. And we can also see what work we've done and got planned. So if we haven't got any work planned, we know what we can start putting into place. But the other thing that was talked about earlier is looking at maximising access opportunities. We know we get less and less of them. With this tool, you can see anything on cyclic top and associated track up to 2 miles. So again, you can start to look at grouping what the defects are. What's the optimal intervention? So rather than doing lots of lift and packs and other things like that, little small interventions, what can I do over a bigger area that maybe stops 10, 12 L1s becoming tomorrow's L2s? That's part of what we're trying to do with the tool as well. So again, another incident. This was highlighted on West Coast Mainline up in Carlisle, where they had a suspect of a cyclic top, but they were going to, they had a tamper planned, but initially were going to pull it for hot weather, but decided that the risk of the cyclic top overweighed the risk of the tamper, so they still did the shift for the tamper. Didn't affect the track for the hot weather, but it meant they had a stop to speed going on the West Coast Mainline, which again would have been sat there for a number of weeks until it came off, but they stopped it going on, therefore saved some money. And again, this is about how we can look to utilise the tool to help us make decisions. What's coming now? So the one that's missing off here is the one Rob will talk about in a minute, which is RBM. But coming in July, we'll have track quality. So this is where your CCQ charts will start to go into Insight, and you'll be able to do track quality reviews through Insight as well. And it will then also start to show you again predictions of when track quality is going to go through satisfactory to poor, anything up to the 2 years. The further out we try and predict, obviously the less accurate we get, but at least you've got a good heads up for the next 2 years. Plus you know all the defects that are affecting that track quality. And it might just be 1/8 out of a mile, but you can then, again, target in more. The big one for us is in October, around October is when we integrate with Ellipse and Tiger. So everything you do in Ellipse and Tiger today, you can do through Insight, and the two systems will talk to each other, or three systems will talk to each other. So if you want to create do a review of your track quality or a defect within Insight, you can do it. You can create the work order. That will then flush through to Ellipse. So no need to use and have 3 or 4 different screens open when you're trying to do your track reviews. Digital trace review will come a bit later. This is where you can then start to look at the traces on Insight and annotate them. So instead of having to write on the PDFs and store those, you'll be able to annotate it within the tool and store those comments. Those comments are also visible because a section manager or section supervisor going out on track with an iPad can see exactly the same data. And that's the whole idea, that it's there available for everybody to use. It's available on multiple platforms and devices. And then straight on is linear review and query builder. Query builder is going to be a great piece of tool that if we've had a broken rail in Scotland somewhere and we know all the factors that cause that broken rail, somebody can then set a query going across the whole country, and you across the whole country can go, oh, I can see 5 places where I've got similar issues, and therefore do I need to go and treat it before I end up with a broken rail as well. And then rail management, and the big one, going back to Peter's sawtooth, around intervention decision support. So how effective is what we've done in the past? When do we need to stop doing things in the future? When do we need to stop tamping and stone blow? All that will be starting to be built. So again, optimising forward planning of access opportunities, optimising equipment usage, and therefore, again, being a lot more proactive rather than reactive. And that's the way we need to move forward with this going forwards. So I'm going to hand over to Rob now, who's going to talk you through risk-based maintenance element of the Insight tool.
Thank you, Paul. So, as Paul said, the latest functionality that we've introduced into Insight is the risk-based maintenance. This is designed to help maintenance teams manage their RBM regimes on a day-to-day basis. If you have the right permissions, you can come into Insight, you can configure the rules, you can set your thresholds to be what you need them to be, so you can set your dips at 20 millirads, 18, 15 millirads, you've got that flexibility. And then Insight will automatically create those defects and it will create it with the severity of RBM, so you know that that's an RBM defect. We also can configure within the tool what your remedial actions are based on your regime. So it might tell you you've got to go and do your scoping inspection, it might say you've got 4 weeks to do that, and it will calculate and then work out the date that you could go out and do that. Also within the rules, also, as well as that, it will have your failure modes, so the particular failure modes are relevant to that defect. You'll select those, or you can select those, and it will again tell you what actions you've got to perform and when you've got to do it by. This applies to PLPR and to the geometry train defects. So you can kind of manage your regimes, and it will provide that additional audit capabilities. But it also makes it much easier for you to manage multiple regimes. So if you've got an S&C regime, a plain line regime, maybe a separate regime for your long timber bridges or for your tunnels, you can cope with all those different rules. Insight's working all that out for you, and you're not having to go and check the documents manually and try and work it out in your heads. Let me move on to the next one. So another sort of feature within Insight that's particularly useful with RBM is our persistence logic, and I think a lot of you would have heard me talk about this a lot before. But the idea is that obviously you might record a defect on run 1, and if it's an RBM defect, you could have 18 weeks, you could have 96 weeks in which to fix that. You might have gone and done your scoping, you know what you've got to do to fix it, and you put all that information against the defect. You might even plan some work against it. Then you're going to be told about it in the next run, and the next run, and the next run. Insight remembers that, and it will keep all your decisions you've made on each version of that defect, so you're not having to go and reconcile those manually each time. What Insight also does is it recognises that if that defect has now got more severe and it's perhaps gone above your intervention level, it will tell you that you need to go and look at it. Again, you've got to review the work that you've carried out or you've got planned against it and potentially bring that in. You might have to fix that now within 14 days. So it's kind of managing all that for you, taking out the paperwork, the legwork involved in that. We see RBM is useful functionality now in terms of what we've introduced, but actually we see it as being a real opportunity to transform maintenance. A lot of what's been talked about today, I think, can be built around the RBM framework. If we think of RBM as your P2F curve, we are identifying point P's. At the moment we're using the threshold, the RBM threshold, to say this is a potential failure. And then we're using the failure modes and the defect information to predict when it's going to become a failure. And then obviously you plan your work to prevent that from happening. But we can become, now we're systemizing, we can become a bit more sophisticated. And your sort of point P is a trade-off, isn't it? If you set it too high, if you set that bar too high, then you don't have enough time to react to it. If you set it too low, then you're going to be swamped with too much information. So if we can be more sophisticated and actually start saying, well, what happens with combinations of defects? I might be particularly interested in dip angles where I've got an RCF site or something at 20 millirad, but the rest of the time I don't want to see them. So we can start to use Insight to filter out those ones that are particularly interesting. We can also become more sophisticated about how we define the P2F curve and the timescales for that. So you can start considering factors like usage or weather. How's that impacting on our predicted degradation and when we need to interact with that. And that's where Insight's bringing all that information in and enabling you to refine that and be making sure that you're carrying out the right interventions at the right time, at the right place. So I think what we've got, how are we doing for time? Got 5 minutes. So we've got a video that we'd like to play just to give some feedback from our colleagues and their experiences with Insight.
So cyclic top, previous to Insight, couldn't be identified by review of traces, especially lower category ones. If you're going below a Cat D or a Cat D coming into it, it's hard to visually identify it on the traces. With Insight, that predicts that and it picks it up for us, so then we can then look to either, like I said, plan a tamper to go there. If we've got a tamper at that location, then we'll run the tamper through it as a priority 1 site or priority 2 site, or depending on what track qualities say in the area. But then we can look to pinpoint it early, which allows us to remove the cycles early, so which is less work for maintenance teams or even for the tamper to be doing the work. Because it's like anything, as it deteriorates, you'll get more cycles. The more cycles you get, the more of a risk to a derailment.
When you dig into Insight, however, you can actually look at alert limit faults and pre-alert limit faults. And the good thing about the system is it tells you the timing between each severity. So you start with an alert limit, intervention, and then immediate action. So in this mileage, there was actually a pre-alert and alert limit top left and top right fault, which you can see on the screen here. What it also does, and what's also really good and saves time, is that instead of having to dig out the traces manually, print them off, look at them on either a table or on a split screen and compare them, you can actually do this, and it shows you on Insight, which is this top graph here. So you can select multiple runs. You can start off by deselecting all traces, and then you can select the ones that you want to put back on. Then if you go into a degradation rate of the fault further down, you can actually see which defects you wanted to focus on. If you click into this here, you've got top left fault, top right fault, and developing cyclic top fault over a 9 metre wavelength. Whereas traditionally would have been difficult to to see that on a trace. So this just allows us to capture that fault before it develops into a surface-affecting failure, for example. And that location where that is at Acton Bridge is a 2-line section of West Coast Main Line. So if you have a speed restriction on with the line speed of 125 mile an hour, you're looking to put ESR equipment out 1.25 miles back. So then you're starting to really see delay in train performance and running minutes. I think previously we've had speeds on a bit further along, and it easily racks up into 2,000 minutes, 3,000 minutes, probably at a cost of around £250,000, if not more. So it basically just allows us to do more of like a predict and prevent, as opposed to just going out there and tamping set mileages that we've always tamped. It's always that's been on a maintenance regime.
That's your picture. It's the same. I can draw that up onto my screen and I can go really into it. Which you won't be able to do that on that PDF. I can probably get done in half a day what we just take me folder.
It's a massive time saving. You can review all your images really fast, so you can go through them quickly, scope onto your next one. Loading times are really minimal. Go through what actually is the issue.
In terms of track safety, that's great because you're separating staff from the trains. There will be some instances where you still have to go out and do on-track investigation, but when you can do the majority of it desktop with these type of tools which give you all the information firsthand before you even go out, it means you can focus exactly where you want to go to rather than walking up and down the track looking for something.
But the difference with the Insight tool is it has the cyclic top feature, so we can see like the individual peaks of the cyclic top, which is data we've never had vision before, and we're using that to help sort of prioritise where we're putting OTMs to try and prevent them becoming severe cyclic tops that require speed restrictions. So a couple of examples from the trial we've been doing, and we had one cyclic top site which had a speed on, and the severity was actually due to the number of cycles, not the size of the peaks, so they were quite low dips, but the multiple effect adds up the amplitude. So due to that, it wasn't very easy to see by eye on site, and we tried treating it by stone blower, and it hadn't rectified it, so we'd had to leave the speed on. And we then looked at the Insight tool and we could see the trigger point further out than what we'd originally identified. And we then treated it again with a stone blower and managed to get the speed off. So that was a useful example.
Okay. All right, so I just wanted to finish off by revisiting the question that we asked. Hopefully, the question we asked at the start. So this is a bit of a risk for us, and maybe we've done a really bad job. But so if we can go back to the Slido app, and we'll ask the same question, and we'll see whether anyone's changed their mind. I think that might be coming up. There we go. Okay, well, looks like at least you know about it, so that's good. We didn't just waste the last half hour. And I think there's a consistent theme that it's already helping in some cases, but the future in terms of what we're trying to do is really going to, especially that bringing that integration into Ellipse, I think is really what we need to make it add the real value. Cool. Well, thank you very much. That's off.